So chapter 5.4 is on half angle formulas. We had 5.2, which was on angle sums and differences. We've had 5.3, which was the double angle formulas, and now 5.4 is our half angle formulas. All right, so look at the box, if you've got the box there. These are the identities. These are the substitutions that you're going to be able to make that involve the sine, cosine, or tangent of a half angle. So the angle A divided by 2, so half of the angle A. And you can see that for the sine, it's plus or minus the square root of 1 minus cosine A over 2. For cosine, it's plus or minus 1 plus cosine of A over 2. So the only difference in these two is the difference versus the sum. And for tangent, there's two options. Both are equally, and we could prove every one of these, if we want to take the time to do it, that they are indeed identities, that they're true for every single angle A that exists. So 1 minus cosine A over sine A, or sine A over 1 plus cosine A, either one is perfectly equivalent to tangent of A over 2. All right, so let's look at example 1. So example 1 asks us to find the cosine of 112.5 degrees. Well, 112.5 degrees is not a common angle. I would have to use a calculator or look at a table or some kind of assistance to be able to find that outside of what I'm going to show you. So one way that I can find an exact answer to that is by using my half angle formulas. So just for a second, let's write the cosine of 112.5 degrees as half of the measure of an angle that's 225 degrees. So if you just check that, 225 degrees, half of 225 or 225 divided by 2 is 112.5 degrees. So the cosine of the half angle means I can apply the formula or the identity up here for half angle. So the cosine of the angle divided by 2, the angle being, so my theta or my A would be my 225 degree angle. Would be equal to plus or minus the square root of 1 plus cosine of the angle A or theta or 225 degrees divided by 2. Okay, now as far as the plus or minus, let me kind of box that in right now. This angle is 112.5 degrees. That angle lies in quadrant 2. Cosine in quadrant 2 is negative, so I know which one to use for this. All right, and then from there, this is just simply a matter of doing this little calculation. The cosine of 225 is an angle that lies in quadrant 3. It's the 45 degree reference angle. Cosine in quadrant 3 is negative, and the cosine of a 45 degree angle is square root of 2 over 2. So the cosine of 225 degrees is negative square root of 2 over 2. Okay, so all I did in this step was evaluate the cosine of 225 degrees, and I got that. All right, and from there, it's really just an arithmetic calculation. I want to leave it as an exact answer. I'm not going to put it in a calculator. So basically, I just need to, think of this as 2 over 2 since my denominator is 2. So 1 can be written as anything over itself. So 2 over 2 minus square root of 2 over 2. So I'm just going to say it's 2 minus the square root of 2 over 2. So if I had 2 over 2 here and I combine those fractions together, they have the same denominator. That's what I get. All right, and then it's divided by 2. So remember, dividing by 2 is the same thing as multiplying by 1 over 2. Multiplying by its reciprocal. So I'm going to go ahead and save the step there and just go ahead and multiply by 1 over 2. So dividing by 2 is the same as multiplying by 1 over 2. All right, and so at this point I have minus the square root of 2 minus square root of 2, because that's multiplied by 1 over 2 times 2, which is 4. And that's about, outside of putting in a calculator and rounding it off, no longer an exact answer if you do that. That's about as good as you're going to get on that one. And half of 270 is 135 degrees. Okay, so that would fall in quadrant 2, and I would label my signs accordingly. Okay, so if I am in angle in quadrant 2, sine is positive, so this one's positive. Cosine would be negative, and the tangent would be negative, so this would be a negative as well. All right. So now what? Well, cosine of A, I don't know. I know what the sine of A is. They give me the sine of A. So that's going to help here. So I need the cosine of A in each of these functions. The good news is, going way back to one of our early sections, if you know the sine of angle A, you know the cosine and the tangent. So if they give me the sine of angle A in quadrant 3, so let me draw the angle in quadrant 3. And this has a sine of negative 8 over 17. Sine is the ratio of the opposite side to the hypotenuse. So opposite, down 8, and then 17. What's the cosine? So I can find that. If I can just find the adjacent side, I've got the cosine. So if you need to do Pythagorean theorem, you can always do that. This is a common Pythagorean triple, 8, 15, 17. So if you know that, just saves you a little bit of time of having to go through the Pythagorean theorem to find your missing side. So now I know that the cosine of angle A, and this is negative as well because it's to the left, x is a negative there, so it's going to be negative 15 over 17. And so I now have this cosine and the sine, and that's really all I need to finish these out and then just to do the calculation. So, so this one is going to be 1 minus cosine A, which is negative 15 over 17, divided by 2. This one is going to be negative square root of 1 plus negative 15 over 17 divided by 2. And this one is going to be negative 1 minus negative 15 over 17 divided by the sine of A, which was given to me in the problem, negative 8 over 17. All right, and all I got to do is kind of clean these up a little bit and do the calculation. So this becomes 1 plus 15/17, since it's minus a negative. Think of this as 17/17 plus 15/17, and that becomes 32/17. And that's divided by 2, but instead of dividing by 2, I'm going to go ahead and multiply by 1/2, save myself a step. Dividing by 2, same thing as multiplying by 1 over 2. Multiply by the reciprocal. All right, so I end up with 32 over 34, or I could reduce the 2 and that reduces down to 16/17. Okay, and that is the correct answer. There are some probably more simplified ways you can write that. Well, for one thing, the square root of 16 is 4. And I could even rationalize the denominator. If you multiplied by square root of 17 over square root of 17, and I just was always made to do that, so I can't get away from it. But you guys know WebAssign's pretty generous with the way it takes the answers, so it probably would accept either one of these. It might even take that one, I'm not sure, but you could try it and see. But all right, so cosine. So let me work this one on out. So think of this as 17/17 minus 15/17. That's 2/17 divided by 2. So I'm going to go ahead and multiply by 1/2. Those divide out, and I end up with negative 1 over square root of 1 over 17. Again, square root of 1 is 1. And again, you could probably enter it like that, or if you're like me and you just have to rationalize it, it's going to look like that. All right, let me back up just a minute. I had this function does not have the plus or minus in front of it, so I don't need to add the I know it's going to come out to be negative, but it doesn't have the plus or, so it will happen. The negative will happen as I do it. So this should have been nope, no square root. So I have there's the formula right there. So I need 1 minus the cosine of A, which is negative 15 over 17, divided by sine of A, which is negative 8 over 17. All right, and so 1 plus the square root of 1 plus 15 over 17, think of that as 17/17 plus 15/17, that's 32 over 17, and that's divided by negative 8 over 17. Again, dividing by a fraction, we just multiply by the reciprocal, the same thing as 32/17 times 17, negative 8. If I reduce these before I multiply those, divide out, I can reduce that 8 and that 32, lose 4, And I end up with -4. So if you multiply 32/17 by -17/8, you get -4. And as we knew that in quadrant 2, where the half angle falls, we expect tangent to be negative, and it is. All right, so this is very similar to the previous problem. It does ask me to find all 6 trig functions, but remember that once I find those first 3, all I really got to do is reciprocate those, and I'll have all the other 3. Okay, so let me start again. Sine of a over 2 is equal to, I'm not going to put the sign there yet. We'll figure out based on the quadrant that it's in whether it's positive or negative in just a moment. Square root of 1 minus cosine a divided by 2. I'm going to work horizontally this time. Cosine of a over 2 is equal to the square root of 1 plus cosine a over 2. And the tangent of a over 2 is, I'll go with the same formula I used last time. I could use either one of them, but okay. So I basically need to know the cosine of a and the sine of a just like last time. I know the sine. Let me just come up here in the margin where I've got a little bit of room and just draw that out. So between 270 and 360 is quadrant 4. So this angle falls in quadrant 4, where the sine is opposite to hypotenuse, is -7/25. And so again, I can use my, if you know the common Pythagorean triple, 7, 24, 25, or you can do Pythagorean theorem to find that. So the cosine of A is adjacent to hypotenuse, so 24 to 25. Okay, now as far as the sines on these two, we're in quadrant 4, so between 270 degrees, and so the angle A falls between 270 and 360, which means the half angle, half of that, would fall between half of 270 and half of 360, which would be 135 to 180. So it falls between here and here. So again, it's in quadrant 2. In quadrant 2, sine is positive, cosine is negative, and tangent should also come out to be negative. Okay. Now it's just a matter of substituting in my cosine and my sine and cranking out those calculations. So positive 1 minus 24/25 divided by 2. So think of this as 25/25 minus 24/25. That's 1/25. Dividing by 2 is the same as multiplying by 1 over 2. And I get the square root of 1 over 50, which, of course, square root of 1 is 1, square root of 50. Again, I'm sure WebAssign probably would accept that, but if you want to rationalize it, this becomes square root of 50 over 50, multiplying by the square root of 50 on top and bottom. And then I can break this down and take out, there's 25 times 2, and the square root of 25 comes out as 5. And then I can even, 5 over 50 would reduce down to b. Okay, so if you want to rationalize it, if not, I feel sure it probably would accept this. It always has. All right, cosine of half the half angle would be negative 1 plus the cosine, which is 24/25, divided by 2. So this is 25/25 plus 24/25, which is going to be 49/25. Again, I'm not going to multiply by 1/2. So this becomes negative square root of 49 over 50. And since 49 is a perfect square, we might as well go ahead and take that out. All right, so again, if you type that in, enter your answer that way, I feel like it would take it. I'm going to go ahead and rationalize it. It would become negative 7 square root of 50 over 50. Breaking this down into 25 times 2, bringing the square root of 25 out is 5. That would be negative 35 square root of 2 over 50. And then you could reduce 35 and 50 even down even further and make that negative square root of 2 over 10. Or I said 7 square root of 2 over 10 if I... Okay, yeah. Okay, and the last one, the tangent of the half angle 1 minus 24 25ths divided by negative 7 25ths. This is 25 25ths minus 24 25ths. It's 1 25th. Instead of dividing by negative 7 over 25, I'm going to multiply by negative 25 over 7 and divide those out, and I end up with negative 1 over 7. Okay, and there is your tangent. So to get it did ask for all 6 trig functions. So let me come over here. I've got the sine, cosine, and tangent, and those are boxed in a couple different answer options there. But the cotangent, the secant, and the cosecant are just going to be the reciprocals of. So cotangent is going to be a reciprocal of negative 1 over 7, which would be negative 7 over 1, or just negative 7. Secant would be the reciprocal of the cosine. So since I would be better to flip it over here, since I've rationalized it here and put the radical on the top. So let's flip this over. It's going to be negative square root of 50 over 7. Again, I can definitely reduce that down. If you want to take the perfect squares out, that's going to be negative 5 square root of 2 over 7. And cosecant, again, I would flip it over here. It would be positive square root of 50 over 1. And again, there's a perfect square in that, so it's just hard for me to leave it that way. So I'm going to go ahead and rewrite it as 5 square root of 2. So here is your cosecant, your secant, and your cotangent as well. All right, this one asks us to find the tangent of 15 degrees. Very similar to example 1. We don't have, 15 is not a common angle, so I couldn't give that really without looking it up or punching a calculator. It's not an exact answer at that point. I've rounded it off. So what I can do is I can think of the tangent of 15 degrees as the tangent of 30 degrees divided by 2. And then I can apply my half angle formula for tangent. So let me do that. So the half angle, I'll use the same version of the tangent half angle as I've been using. And let me go ahead and, I left out the S anyway, let me go ahead and make this the cosine of 30 degrees divided by 2. Well, the cosine of 30 degrees is square root of 3 over 2. All right, and so think of this as 2 over 2 minus square root of 3 over 2. So this becomes 2 minus square root of 3 over 2. Divided by 2, same thing as multiplying by 1/2. And I get 2 minus square root of 3 over 4. And in quadrant 1, of course, 30 degrees is positive, so, or 15 degrees is also positive. All right, example 5 asks us to graph this function. So, again, we haven't graphed any trig functions, squared functions anyway. So let's try to rewrite this. Remember, this is actually saying 6 sine of x over 2 squared. Same thing. So I can rewrite the sine of x over 2 using my half angle formulas as the square root of, and it really wouldn't matter if it was positive or negative because you're going to be squaring it anyway. It's going to be positive after you square it. So the sine of x over 2 is equivalent to 1 minus the cosine of x divided by 2. So all I did was replace sine of x over 2 with its formula, equivalent, identity, half angle formula. I can now, when you square a square root, those are inverse operations. Square basically undoes square root, and we end up with this. All right, and so then if I multiply 6, maybe it's like 6 over 1, so I could distribute the 6 out there. So I would have Or I could just divide the 2 out. Let's do it that way. So that would be 3 times 1 minus cosine x, or y equals 3 minus 3 cosine x, if I go ahead and distribute that out. Okay, so it wants me to graph this over the interval from 0 to 4 pi. So let's look at the function here from chapter 4, what we have going on. So it's a cosine function. There's been no period change, no horizontal shift. Do have a vertical shift, up 3. Do have an amplitude change. And with the negative, we also have a reflection. So 3 things have changed to alter the graph of y equals cosine x. So let's graph that over 0 to 4 pi. So the period of cosine is 2 pi, so we're going to do it 0 to 4 pi, so let me split that into my 4 equal parts. All right, cosine, the amplitude being 3, typically starts at the highest value, the maximum, but because of the negative reflection, we're going to start at the minimum, crosses the x-axis at 0, up to the maximum, back to 0, down to the minimum. Oh, but I forgot the shift, so okay, scrap that. Forgot all about shifting it. So basically, we're going to shift up 3, so this is going to become my new pseudo x-axis here. Okay, so then I'm going to start at 3 below that. So this is like my 0 now. This is negative 3, 0, 3, 0, negative 3. And that's one period of the graph. And I could continue that and do another period of it since it wants me to go to 4 pi. All right, and right back where I started. So that's 2 periods from 0 to 4 pi. You see 2 periods of the cosine graph. All right, example 6 and last example. So this time we are another one of our proofs. So we're going to try to prove that this side and this side are equivalent. I am going to start with the left this time. This looks more complex to me. So let me start. Immediately I see a half angle here. So I'm going to go ahead and do a half angle substitution there. So this cosine of the half angle, remember cosine is, and it's squared, so again, it's not going to matter what sign it is. So it's going to be the square root of 1 plus cosine theta divided by 2. And that is all squared. So I'm just replacing the cosine of theta over 2 with this equivalent expression. And then it's squared. And I'll bring down the 2 tangent theta. And this is what I'm trying to get to. So I'm keeping my eyes on this the whole time. All right, I'm going to bring that down. And I'm going to go ahead, because I know when you square a square root, I know what happens to that. This just is going to become 1 plus cosine theta over 2. Okay. The 2's I can see right now will divide out. And so I end up with tangent theta times 1 plus cosine theta. A couple things I could do here. I could change this into a sine over cosine, but either way, I feel like I need to, there's really nothing else I could do with 1 plus cosine theta other than, let's go ahead and distribute this out. Let's see where that takes us. So tangent theta times 1 is tangent theta. And tangent theta times cosine theta. Now I have the tangent, so keep in mind where I'm going. So this works. This somehow has to become a sine theta. So let me bring this down and let's do a tangent, change that to sine theta over cosine theta. That's just a ratio identity. And this, if you had to put some unders of 1. And what happens, the cosines divide out, and I end up with tangent theta plus sine theta, which is the same thing as sine theta plus tangent theta. So let me kind of walk back through what I did. So this was a half angle formula. Substitution, just then I just simplified by squaring a square root and simplified that. Another simplifying, just let the 2's divide out. And then I distributed. And then I did a ratio identity substitution, changed tangent into sine over cosine. And then I just simplified. And got to where I needed, so sine theta plus tangent theta.